She blinded me with science.
Welcome to another episode of Chemistry Connections with Mr. Ramsey. Today we're just going to focus on some more practice involving the process of stoichiometry. Let's go ahead and get started. In this first question, we're going to convert 25 grams of sodium bicarbonate, that's just baking soda, to particles, or more specifically, formula units of sodium bicarbonate. Pause the video and give this one a shot, and then watch the solution and see how you did. Okay, as you can see, I've set up a ladder and I put the 25 grams of sodium bicarbonate, that's from the question, into the numerator on the left side of my ladder. Now, this gives me a hint as to what unit should go down here. Remember, to go from grams, you have to go to moles first. So we're going to put the grams of sodium bicarbonate, that's the molar mass. You can use the interactive periodic table to verify that for yourself, and the moles on top. I'm going to go ahead and cross out the grams. I get in the habit of making sure that I have units and labels. Now that also gives me a hint, since I have the moles here in the numerator, I have to put moles in the denominator. And 1 mole of anything is 6.02 times 10 to the 23rd particles. In this particular case, we're talking about sodium bicarbonate or baking soda. So I did 25 times 1 over 84.01 grams times parentheses 6.02 times 10 to the 23rd. I wouldn't bother putting this over 1 because you all know that 6.02 times 10 to the 23rd divided by 1 is just 6.02 times 10 to the 23rd. Practice using that online calculator, or if you have a scientific calculator, and making sure that you know how to use it correctly. When I plugged all the numbers in, I got 1.791453 times 10 to the 23rd. Since the number in the 10,000s place was a 1, I rounded to 1.79 times 10 to the 23rd particles. Okay, in example number 2, you're going to convert 4.82 times 10 to the 24th particles of magnesium chloride to grams of magnesium chloride. Pause the video, try the problem out, and then continue with the video and see how you did. Okay, in this next example, we're converting 4.82 times 10 to the 24th particles of magnesium chloride to grams of magnesium chloride. I always start by sketching out my ladder method, and then what I do is I start on the left with what I'm given, the 4.82 times 10 to the 24th particles of magnesium chloride. And I do that because it helps me to set up the next fraction, because I know the particles have to go on the bottom. And I know that for 1 mole of magnesium chloride, there's 6.02 times 10 to the 23rd particles. So that's how I knew how to put the particles in the bottom and the moles on top. Now that helped me set up for the next fraction where I'm converting from moles to grams. So I knew the moles of magnesium chloride had to go on the bottom. I used my interactive periodic table to look up the molar mass of magnesium chloride, which was 96.52 grams. That's the molar mass. Now, I'm going to show you how I would do this out on my scientific calculator in case you're having some challenges with the calculator. So what I would do is I would use the parentheses, and I would have the 4.82, then times 10. I'd use this x to the y, 24th, close parenthesis. Then I would do times. I'm going to do open and open, because I want to do 1 divided by, and then I'm going to do a open 6.02 times 10 to the 23rd. I'm going to do 2 closed parentheses here. It's important that you know how to use your calculator. What this is doing is it's taking this first number right here and multiplying by 1 over this whole number here. Now then I'm going to do times the 96.52. Now that's over 1, And we all know that 96.52 divided by 1 is just 96.52. So I'm not going to worry about putting that over 1. And do the equal sign, and you can see that I got 772.801. The number in the thousands place is a 1, so I rounded to 0.80. Okay, in this next example, we're going to convert 3.01 times 10 to the 24th particles of CO2 to moles of CO2. Pause the video, give yourself an opportunity to practice here, then continue with the rest of the video to see how you did. Okay, so we had to convert the number of particles of carbon dioxide to moles of carbon dioxide. So I always start over here on the left in the numerator with what I'm given. In this case, the particles of CO2. So that gives me a hint as to what I need to put in the denominator here. I know that 6.02 times 10 to the 23rd particles is equal to 1 mole. So I put the 1 mole on top. And I don't need to go any further in my ladder here. It asked me to go to moles. So then I took and plugged these values into my calculator, and I got 5 moles. Now my calculator said 5. I want to round the 2 decimal places, so I put 5.00 moles of CO2. Practice using your calculator, making sure that you are comfortable, because oftentimes that's where the errors lie. And if you continue to practice using the calculator, you'll get the hang of how to get the correct answer. Okay, in this last example, we're going to convert 153.31 grams of glass cleaner, otherwise known as ammonia, to moles of ammonia. Pause the video, try the problem out, especially trying to get yourself familiar with your calculator and making sure you know how to use the calculator correctly. Okay, so we're being asked to convert from grams of ammonia to moles of ammonia. So again, I always start with in the top left with what I'm given in the problem, 153.31 grams over 1. That gives me a hint as to what I should put in the denominator of the second fraction, so grams of NH3. I always know I need to go from grams to moles before I could go to particles. In this case, I'm going directly to moles, so I don't need to worry about the particles. But if I did, I know that I'd have to use this part of the mole map. So then I took my calculator and I did 153.31 times 1 over 17.03 grams. It gave me a calculator answer of 9.002. And the 2 is in the thousands place, so I rounded to 2 decimal places, 9.00 moles of ammonia. Thanks for watching, and I'll see you next time on Chemistry Connections with Mr. Ramsey.